Today we're working in Module 2, Lesson 6, and our objective is to connect area models and the distributed property to partial products of the standard algorithm with renaming. So this is going to be very similar to Lesson 5, however we will have renaming in this lesson. The first expression that we see is 64 times 73. In lesson 5, we would have drawn an area model similar to this, but it would have not have been divided into 4 sections. It would have been divided into 2. And we would have written 64 along the top, and we would have decomposed our 73 into 70 and 3. With this particular expression, we cannot easily multiply those numbers without having to rename and bundle, and so we're going to break this into 4 sections. So we'll decompose both 64 and 73. So along the top of my area model, I will decompose 73. So I'll break it into 70 and 3. Along the side of my area model, I will decompose 60. So I'll break it into 60 and 4. And I'm going to go ahead and mark here between 70 and 3 and between 60 and 4 that I need to add those together to remind myself that those numbers are connected and that I need to add my products together once I begin solving this. So 4 times 3 is 12, and 4 times 7 is 28, so 4 times 70 would be 280. Now when I add 280 and 12 together, I get 292. And so that is going to be the first partial product in my standard algorithm. 4 times 73 is 292. Now I'll go ahead and move on to the next section of my area model. Now I have 60 times 3. And 6 times 3 is a more basic problem to solve. So 6 times 3 is 18. So I know 60 times 3 is 180. And now I have 60 times 70. And I can look at my more basic facts in here, and I can see that I have 6 times 7. I know that 6 times 7 is 42. So 60 times 7 would be 420. So 60 times 70 would be 4,200. You'll see as my factors increased 10 times, my answer also increased 10 times. Now we have 4,200 plus 180. That would be 4,380. And I'll add that in as the next partial product in my standard algorithm. And we know now my next step is to go ahead and add those together. 2 plus 0 is 2. 9 plus 8 is 17. I have to make sure I carry my 1 over. 2 plus 3 is 5 plus 1 is 6. And then I have 4. So I now know that 64 times 73 is 4,672. For our second expression, we have 814 times 39. So you'll see I've broken my area model into 3 columns because we have a 3-digit number, and 2 rows because we have a 2-digit number. So along the top, I'm going to decompose the number 814. I can decompose the number 814 into 800, 10, and 4. And I can decompose the number 39 into 30 and 9. And I'll go ahead and mark over here my standard algorithm, 814 times 39. And now we'll go through and just multiply each portion of our area model. 9 times 4 is 36. 9 times 10 is 90. And 9 times 800, well, that's a little harder, but I see that I could multiply 9 times 8. And 9 times 8 is 72. So 100 times more than 72 would be 7,200 or 7,200. Now I need to go ahead and add these together. So 90 plus 36 would be 126. And when I add 7,200 plus 136, that gives me 7,326. And so that's the first piece of my standard algorithm. That is my first partial product. I move on to the second part of my area model. Now I have 30 times 4. Well, I know 3 times 4 is 12, so 30 times 4 would be 120. I have 30 times 10. I know 3 times 10 is 30, so 30 times 10 would be 300. And I have 30 times 80. I know 3 times 8 is 24. 30 times 8 would be 240. 30 times 80 would be 2040. And so 30 times 800 would be 24,000. I need to go ahead and add each of these together. I know 300 plus 120 is 420. So 24,000 plus 420 would be 24,000. Oops, let me go ahead and erase that to make sure that all of my digits are lined up appropriately. So 24,000. So we'd have 2, 4, and then my 420, 4, 2, 0. 24,420. And our next step is simply to add. 6 plus 0 is 6. 2 plus 2 is 4. 3 plus 4 is 7. 7 plus 4 is 11, so we need to be sure to carry our 1. And 2 plus 1 is 3. Our answer then for 814 times 39 is 31,746. Again, we were working in lesson 6 of module 2, and our objective was to connect area models and the distributive property to partial products in our standard algorithm with renaming.